Okay, so this one, do they work with camp? I felt I had to disclose something like that. Maybe at the last minute. So you may recognise it as very much like it's a vacuum cleaner that puts the Arduino on basically some of the software. So you've got a few seconds to start and set that. The Arduino is just controlling everything. I'm facing that stop. So it's just doing simple manoeuvres. It's got a couple of drop sensors on it. So if it bumps into something it can't change. It's purely a cable challenge. But it will just, if it hits both sensors, it reverses and always goes the same way. If it hits one, it tries to reverse and turn parallel to wherever it's supposed to, whichever side it's hit. As your batteries are inside, that pair is just a counterweight. Too much spin on it. Yeah, I thought about slowing it down so that it didn't do the emergency stop, but that is when it slammed on the brakes every time. Sit there and dance around the table. Yeah. Well, next time I would hope to actually try and improve the mechanics, because having moved to the country fairly recently, most of my stuff is still in boxes. I tried putting something together with a hacksaw and exacto, and decided that it's actually easier to put it all back in the case it came from. So one of those looks like inside. Okay.
What kind of sensor?
It's actually the Nito drop sensors. It just gives you an analog voltage based on distance. I think that one. Yes, infrared. Yeah, I think I got it set to about 4 inches. So if I do that, it'll quite happily fall off the edge. It doesn't really take a big enough drop.
Okay, very good.
Okay guys, see some familiar faces. Those of you who I haven't met, I'm Jared. These are Romebos, and these are designed specifically to help children with autism practice communication. So we've created a very simple interface that's on an iPad, very education friendly. A lot of teachers have iPads. And we've made an interface that makes it really easy to deliver lessons, prompts. We use the Siri voice library. So it can say anything you want and customize it specifically to the student or child. And can you guys hear me okay? Yeah, okay. And so they drive around, really compelling. Apps on iPads have been helping kids with autism for years now. We've seen that. That's my background as an autism educator. And the main problem with iPad apps is that you're trying to teach kids that have social and language difficulties. Trying to get them out of that, and they're doing this with an iPad. And so this is a more connected experience where they can play with communication, and the kids like playing with it themselves too, using it as sort of a personal avatar. And yeah, so you can check out origamirobotics.com or romebo.com. I'm here because I need tinkerers. I'm an educator. I've adopted this project. It was created before me by a brilliant researcher named Aubrey Shipp. But I need some help getting it to the final mile to get it on the Kickstarter. And I need some help developing the kit. And I've been working with Osman's here. I saw Osman. And Osman over there. And Ted at Ologic. Ologic's been helping. They've created a custom board for us. And we're just ready to go over that final hoop to get on the Kickstarter and have something that will hold up to some views, some play. And if anyone's interested, come and see me. I'm thinking about doing like a little after party on November 8th, maybe a couple weeks. Just you heard me sitting over there. That could be fun. Oh yeah.
Is that a new one?
This is actually an older one.
Oh, okay.
We'll see. We'll probably do a coat or one like this with a coat over it for the final Yeah. Sorry. Let's get that. So we connect. So they connect over Bluetooth.
Sorry, seems I have a little stage fright.
You have
Ready to go.
your steering. This one's a little wonky. So this is using an older version. So the one that we're working on now, we need to get the circuit board to steer better. Some really basic things. But on the interface here, we have these collections of buttons, which we call palettes, and we have different collections of buttons for different stories or scripts or lessons that we're trying to teach. We can have one about brushing your teeth or going to the doctor and what that's going to be like today, or feedback for how they're doing in a class. And we might say something like,
That's wrong.
you can hear it. It's using Siri. It's really nice. So it's an iPod in the front. And another advantage of using the iPod is that we will be able to create an SDK so that it can interact with other educational apps. So we can have Romevo do a little dance or say great job when the child completes a puzzle or whatever it may be.
Do you see the magic crown?
So we can do
We
little,
want the beach.
and educators can create their own buttons, customize it to the student, and they can just say names off the fly.
Lily.
Anything you want that you type, it'll just say right away. You can save those, and then we have a backend written in Ruby that EdCats students built for us. EdCats helped out a lot with this, so we can save these palettes, fetch them, synchronize them with the iPad, and educators can share them with their team or with other people that are working with the student. Yeah. Any more questions? Yes, come see me if you.
So this is obviously a two-wheel balancing robot. It's kind of a sub-genre of robots. It's something that I've been interested in for really since I've been into robots. I don't know why they've always just fascinated me. Because it's more of a kind of a technical challenge. There's often a lot of math in building one that can balance. This particular guy was built for a competition that was sponsored by Servo City, which is one of the popular sellers of robotic parts. And they have this system called Robotics, which is these metal channels and brackets and pulleys and belts and all these things that you can put together to build a robot really easily. It's actually the best. There's other systems out there. There's Vex, Tetrix, is that another one? This is actually the best one that I've seen. It's a very well-developed system. So anyway, they had a contest to build a two-wheel balancing robot out of their system, and the prize was $1,000 worth of parts. So they don't actually give you money; they just give you more of their parts. So you can build more robots and more competitions. So I showed him as a frame last month. And actually just got him finished and balancing just on this past Friday. So I created my video and submitted it on Sunday. You can see a video of him in various situations, like in a warehouse, outside our backyard, helping my wife in the yard, carrying stuff. Kind of like some pretend little situations that you might find a helpful robot in. So the video is at ozbots.org, ozbotz.org. That's my website. See, he's still not a perfect balancer. He's got an oscillation, which just started balancing 5 days ago. So I haven't quite worked out all the kinks.
But you launch very well for
So there you go. Oh, so some of the parts are 3D printed, like his hands, the neck. One requirement of the contest was that it had to have a phone at the top. It's kind of an arbitrary requirement. I think that the goal was really require. It didn't have to be an Android phone. But I think their intention was that you might want to use it like as a telepresence robot. You know, you can let Skype on the phone, sit at your computer, and drive around. It actually showed that on the video that I have here. So there you go. I don't know what red stands for yet. Other than the color.
Maybe it's like
Really excellent droid.
robotics car.
You know what this stands for.
Work on that.
Excellent droid.
Really expensive droid.
Excellent.
Wow. 30 years ago, I picked up a book, How to Build Your Own Self-Programming Robot by David Heisman, and it changed my life. It's a wonderful book. It's cursed. This is a robot, Rodney Jr., and in David Heisman's book, he basically describes machine intelligence. And it's actually very simple. The robot's goal in life is to move. And the way I detect motion is with an iRobot stall sensor, okay, called a mobility detector. And basically, with the differential drive system, you basically get 9 possible motion codes, including stop, if you consider that a motion code. What I realized is that every one of these motions has no magnitude of displacement except forward and reverse. It's the only thing that's really interesting. So the goal of this machine intelligence is to maximize displacement or magnitude. The robot's basically learning forward and reverse, and it isn't so much what it does, it's how it does it. Now, again, in the book, he enumerates 3 levels of machine intelligence, alpha, beta, and gamma. In alpha, the robot basically does random motions until it accidentally discovers forward or reverse. Spinning the little wheel makes it happen. It's a little emitter and detector here. In beta, when it's in a particular motion pattern, when it encounters a stall condition, does random motions. When it finds a motion that succeeds, that is, makes it move forward or backwards, the only motion patterns with any magnitude, it remembers that. So the next time it's in that motion pattern and encounters a stall condition, it goes to its memory of the successful response and does that. Then in gamma, when the robot encounters a stall condition in a pattern that it doesn't have a successful response, it goes to other high-level successful responses before reverting to an alpha level, just random motions to try and discover forward and reverse. So I always say that I'm going to bring this in, and it's going to be level 3, and it never is. Okay, I've got alpha. I've had level 1. I've shown it, I think, for 1 or 2 years. But this phase 3, I scaled back my plans, and I said that I would show up and demonstrate beta. And so, with a little bit of luck, here's Alpha Junior displaying machine level beta as described by David Heisman in How to Build Your Own Self-Programming Robot. Without any further ado, oh, by the way, I'd like to apologize for the second inning last night. That's a joke. Okay, so here it's doing random motions, trying to discover forward and reverse. Again, it's not what it does, it's how it does it. Hang on a second. I'm going to do a reset here. Shouldn't affect it. Again, it's just trying to go forward and reverse. The only intelligence it has is monitoring that encoder to see whether or not that wheel is spinning. Part of the trick is discovering reverse after you're doing forward, and then discovering forward after you do reverse. And then it gets into an oscillation. With a little bit of luck, we'll see that. And the concept again is with gamma, it discovers forward and reverse, the only two motion patterns with any magnitude, sooner and sooner. You can apply this to other activities. You could add other sensors. And again, it's not that you're hard coding the program to do this and that. You're coding it to do something successful randomly, and then, okay, I'm trying to do the same thing, but I don't have any memory of any successful response, or you do, and then I'm gonna try it one more time. If it doesn't work, I'll give up. Well, I won't give up. I'll cease the demo. Okay, one more time, with a little bit of luck. Anybody got a score?
3-2.
The World Series Game 7?
3-2.
3-2?
2 down.
3-2?
Yes.
We're in the lead? Yes? Yes? Okay.
Bumgarner's on the mound right now. And
Play-by-play by John Carlini there. One more shot. This is Arduino. It's basically an Arduino with two continuous rotation servos, and it's just monitoring the encoder disk here. I can't even blame it on poor battery power.
really, that's number one thing to do.
Well, you can usually blame it on that.
Batteries are famous. What do you got?
Yeah, okay, so we should have reverse for forward. Now if it can discover forward from reverse. So it's trying random patterns to do something to eliminate the stall condition. Okay, it should do reverse from forward. It should not, oops, that wasn't good. Give it 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Okay, that's it. Thank you very much.
The last meeting, as I was just about to go out the door, Camp called me. And if Camp ever comes up to you and says, what you need to do is run. So he says, here, what you need to do is take a Nito, and all you need to do is hook it up to a computer, and I'll send you a message. So I got home, and sure enough, I had a message shortly. I hadn't touched a Unix or Linux-based system for 11 years since I left Agile. I worked at Agile also. In any case, I hadn't touched one in 11 years. And this last month, I don't know how many hours, but my wife could probably tell you I've spent on this thing. I didn't know what there's a thing, I think I pronounced this right. Ubuntu is what? It's the operating system. It's Linux, basically. And then there's a thing called ROS that I knew about something coming to these meetings. And apparently I'm using a thing called Indigo, which is kind of the latest version of that, apparently. Now, one of the things that I've used in this thing is, besides some messages back and forth, quite a few messages to Mike Ferguson, who Mike has helped me a lot at camp, and I communicated about once a day for a while. They kept giving me tips of what to do, and I kept learning and learning and learning. And I kind of got into a mode. How many of you have ever read Isaac Asimov's book on numbers? Probably some of his out in the 50s or 60s, something like that. There's a thing called the infinite monkeys theory. Put enough monkeys on enough typewriters, an infinite number of monkeys on an infinite number of typewriters can type everything that could ever be typed, right? Instantaneously, it turns out. Well, so I tend to use just part of that, not the instantaneous part, but the infinite monkeys, by trying everything I could think of. And Camp and Mike had promised me after the meeting, they're going to try to give me some more tips, right?
Yeah.
Right. Okay, so far what I've got going here, and I'll just take a couple more minutes, You can see there on the screen, that's 2 windows. I have one of those is running the ROS core and is actually has the Nito. It's talking to the Nito. And then I have a terminal program that is talking through to the ROS that allows me to control this. Now there's a whole thing in this, there's mapping software, and I did get that sort of kind of working. And Mike's going to tell me what I'm doing wrong because it works. I can run the, it's called a LiDAR unit. I can get that going, and I have had some success getting the mapping software like this hotshot robot that was running around here a while ago. But anyway, I've spent an inordinate amount of time, and my plan is this next month to spend at least that much more. I'm trying to hopefully have the mapping stuff ready by the next time. Again, I want to thank Camp and Mike for having helped me get this thing this far. Let me give you just a quick shot. Actually, just a good button to know. And to it. And get your fingers in the right position. You actually make this thing just inch like that forward. It's good for you. Power source all the way up to this. There we go. Push forward, backwards. Forward again. And then let's try to rotate. I actually get to dance. I thought about putting a big spider on top of it. I thought it'd be good for Halloween, right? Okay, so that's how far I've gotten so far. That's the most worth of work. Hopefully in another month I can have the mapping software working. And I'd like to figure out how to make this thing run around by itself. That's the next step after that. That's it.
Very good.
Hopefully it's funny. So when I first got into robots, I was working with the bipeds that were 16 inches tall, and they had a little battery pack, and I made the mistake of building my own that looked like a supervised device. Nothing in my pocket as I got to visit the airport. Security. After the anal probe, everything was fine, but I realized that it wasn't a bomb. I know it looks like that. So I made this yesterday in the hopes that I could run a completely untethered walk of Watson, and this Pac-Man old program So we're going to run them on the battery. It's not untethered. The other thing is that I made the mistake of using a wireless connection that only seems to work with my router at home and not here. So we have to switch that to an ad hoc for the wireless adapters. Junk, and that's another story. So I don't know.
Network won't allow 2 devices to sync load. So if you ever have to do 2 devices sync load, bring your own router.
So the other story is that I always kind of go by what Captain Kirk Samuel he said when he had to put these dilithium crystals in that were polished into the lithium chamber. There's Scotty going like, we've got to run some tests, and he goes, well, test it in battle. So it's like, yeah, that's me. I'm going to go test it in battle. So I brought this here to test it in battle and it failed. That was the good one. So can we get a camera over here? Camera.
Can I talk about?
You want to say something?
Can I talk about AI?
Yeah.
Before we run it down. Oh, we'll do it while you're doing the demo.
No, that's all right.
Okay, I don't know if you guys were here last month when I showed the learning algorithms that are in this robot. And he's not quite learning in real time yet. It took about 3 minutes for him to learn how to walk from scratch. And I remember we also tried to test Mini Watson in battle last month. We brought him up here, and the servos were hooked up in the wrong orders. So that was kind of catastrophic. So we got the servo numbers correct, and we've taken the data from the machine learning that learned how to walk in the simulator, and we've applied the data now to the big robot, which is what we're going to see him walking for the first time, hopefully.
And he's never walked on a rug before, carpet. So
That's the other thing. In the simulator, it was a nice, smooth, perfectly level
yeah,
surface.
and he's got rubber feet. So we're not sure how that's going to work.
He's got big feet.
Reality and simulator very rarely match.
Okay, so here we
We'll
go.
see what we can do.
How far is he gonna go? You guys want to move that?
We don't know how far he's going to go.
Whoa! Dude, man, Michael
It does
Jackson.
have sensors to correct.
Yeah.
Oh, see, his feet aren't going high enough. On the wood floor, he just kind of slides. Come on.
And
Get
the other
off
thing is,
the
it was the
ground.
model of the smaller robot that learned how to walk. It's sort of the same proportions.
Oh, come on. You can move that leg out a little more.
Why are you standing on that side?
Yeah, see, he was walking because could slide that toe along the floor, and it's getting caught
You're
right
trusting
now.
the sensors too much. Please
So, yeah.
be ready to touch him.
It's like Michael Jackson.
He's moving like a millimeter at a time.
Basically, we're the principals in a team called Team Walk Like a Man. We're entered in the DARPA Robotics Challenge, and we started a
That's
meetup
the
group
line.
called Bay Area Biped Robot.
Board or something.
With, I think, 168 members. 3 of them actually show up from time to time.
Hey, let's set him up here.
So, if you're not already a member, you want to join and help us get this robot get ever so slightly better every month, we'd love to have the help.
I would stay away from
The machine learning algorithms are homebrew that I kind of came up with myself. It's a combination of
forgot, it's not this.
Bayesian recognizers with thin layer neural nets.
Are we feeling lucky?
Stand back. Stand back.
They're going to attempt the table challenge.
Careful. Stand up, no kidding.
Yeah, you don't want to sit there, bud.
All right. There we go. If you go to Coursera, there's a really neat machine learning. Perfect. There's a great machine learning class that's for free. If anybody's interested, learn how machine learning works. Coursera has a free course that's currently going right now. So if anyone's interested in machine learning, regression, neural networks,
Awesome.
gradient
It's getting
descent,
better
that sort
every
of
month.
thing, you can learn about it and play around with it yourself. It's kind of fun.
Gopher. Yay.
This is homebrew.
Put him on the table up here. You want a hand? Need some help? You got it? Bring it this way. Put it down here.
Not good enough. And so I'm part of the SV Ross sample return. So we have a lot of smart people who are figuring out how to find the samples, but then we actually have to pick up the sample. And it's pretty challenging because the samples are different sizes and different shapes and are on a grassy field. So while it's pretty easy to pick things off carpet, picking them up off a grassy field is going to be a little difficult. Now we researched some of the other teams, and they were using fairly complex hands. And my inspiration was a machine called a digger, And a digger is used for strip mining. So it has these big gromping teeth that go around on a roller and a conveyor belt underneath. And it just, you know, totally rapes the environment. And I figured, you know, don't use the settle techniques because we have to, you know, do something that's simple and reliable. So my idea is one motor that does everything. And the platform is an old platform that I've been working on. It's a modification of the rocker bogie that they use, that NASA uses on its rovers, except mine uses pneumatic cylinders that are cross attached. So the name of the platform is PIMP, or Pneumatically Influenced Mobility Platform. That's my story.
Gopher's pimp.
Pimp, yeah.
Sorry.
Gopher was the other guy. Pimp is this guy. Pimp is outside, Gopher's inside. And you saw a successful sample recovery. That's it. I'm done.
All right.
You need to take it?
Yeah.
You got that okay? Alan, can you carry something for
This
you?
is so I did Robo Magellan at the RoboJam this summer, and that was quite a thing to try and put a robot together in like 3 months. I built this. Camp gave me the chassis. Thank you very much, Camp.
Right.
And I built the robot from about April till June, and kind of got it off the shelf the other night. See, I need to get something to be like screen sharing or something like that. Mirror? Yeah. I don't even see the display preferences.
Just drag it onto that screen.
Oh, okay.
Hopefully.
Yeah.
Okay.
Yeah, there we go. Okay, so there we go. So, yeah, it's really high resolution too. So probably like the main thing I've been working on over the past couple weeks, because I had to do this like really quick, and I had really like no time to do just pretty much anything except just kind of throw the robot together. So on the right you see what I ran with this summer, and just last weekend I kind of got the robot out and dusted it off and parched it up and just kind of turning things apart and did the thing on the left. So goodbye wire salad and hello, everything is kind of soldered down and hooked up properly, and that's the start of kind of rehabbing it. We have some other circuit, actually have like some little chunks of perf board that you can see in there that used to be just a bunch of wires all taped together. So robot's kind of coming along. Oh, and new bumper on the front. So we have some big heavy switches. It's the little ones that I was using that I got from SparkFun. A buddy of mine gave me this big, huge, like 120 amp Monstro things for bumper, and which was also a bit of an interesting switch in some code, because the little ones that I had, they got all beat up this summer, were normally open, and these are normally closed, and they're, for some reason, I ended up like having to totally rewire like the capacitors and everything that I have on the circuit that I have on here, because they were causing the board to reset. So it's a lot of electrical improvements, no real software demoable improvements. It's not going to roll around it's not going to wheel around the table, but kind of getting things sort of properly done for next year. So that's pretty much about it. Thank you.